Hello once again, our most developed student. My name is Confident and welcome to our continuation of our revision guide where we are looking at the wave, sound and light for grade 10, and we have already looked in the previous two lessons. We have looked at the transverse pulses, the transverse waves, and now we're going to continue with this part, and if time allows we're going to look at the longitudinal waves. So we have looked at quite a few stuff here, and I'll encourage you to grab hold of the previous two videos if you have not gone through these. So we, as I said, we looked at this part of the transverse waves, and we looked at the definition of a crest, a trough, a wavelength, the rest, and the amplitude, and we did sketch some of these. And we also looked here at the pendulum and then the vibration and how this converts into a wave. And then now this is where the lesson actually I just want to bring it from. In the previous lesson we looked at the definition of the period, frequency, and then we looked at this we explained to say frequency is inversely proportional to what? To the period. Very important definition, as well as vice versa, to say period is equal to 1 over f. And then we looked also at the formula for the speed of a wave, which we concluded that v was equal to frequency times lambda. No, f lambda, that's a common formula that you need to remember. V is f lambda. This wavelength is, this sign is called lambda, like lambda, something like that. Is a Greek word for wavelength. All right, so we say the wave speed is not affected by the wavelength, but we're going to talk about that. And then there was an activity that I said you must do, which I want you to check against your answers here. Check for me. Says effect of wavelength on speed, and this is what we want to investigate here. We're going to calculate the wave speed. Remember the formula, v is f lambda, frequency times wavelength, and they have gave us what? The frequency and the wavelength. So v here is f, which is 2 times 1,75, and then this side v is equal to what? Frequency, which is 3,9. It doesn't matter even if you say 0,9 times 3,9 is the same, times 0,9. and then what about the other one? V is equal to, we can even say 1,19 times 2,1 is the same thing, and v is equal to here 4,2 if I'm to follow frequency times 0,6. right? So let's see what it's giving us. Look at the answers here. Remember, velocity is measured in meters per what? Per second. So don't lose that. It's still the same. First one, 2 times 1,75. What did you get? It's 3,5. Second one, 3,9 times 0,9 is equal to what? 3,51. If I round off again, it's 3,5. And then what about the other one? 1,19 times 2,1 equal to, I'm getting 2,499, which is 2,5. So the other one was 3,5. This is 2,5. 4,2 times 0,6 equal to, and this is 2,5. So here you are getting 2,5 meters per second. Rounding off here also it gave us 2,5 meters per second. Rounding off here gave us 3,5 meters per second. I'm rounding off to one decimal place. 3,5 meters per second. Now I want you to look at this. Look at the medium, because we said the wave speed is affected by the medium. Remember the previous lesson? We said wave speed is affected by the type of material, and this type of material is the medium we're talking about. And I mentioned there are 3 types of medium: the solid, the liquid, and the gas. So the gas part here, look at air. So we've got 2 waves here for air. I mean the waves that are 2 different waves that are traveling in air, but look at their wavelength is different. And the interesting part though is that the speed of these 2 waves is the same. So do you see that the wavelength even if it changes, it doesn't affect the what? The speed of the wave. Even if you say the wavelength was 1,75, 0,9, but the wave speed is the same. Hence, this question, effect of wavelength on a wave speed. We can here also say the wavelength here, does it affect speed? No. The wavelength has no effect on the wave speed. Look at the second one. The medium was air, water. If liquid, this is liquid, the wavelength changed from 1,19 to 0,6, but did it change the velocity? No, 2,5. What are you saying? That when the wavelength is changing, also the frequency is changing. But remember the relationship, wavelength is 1 over what? 1 over air. Actually, no, that's not the one. But what we are saying here, I was actually mentioning the previous one to say frequency is 1 over t. But even here, look at the wavelength and frequency. When they are not directly proportional but inverse. When the frequency increases, the wavelength decreases. Do you see that? So look at it. Frequency is high, wavelength is less. From the top, it was 2,1 to 4,2. The wavelength was 1,9 to 0,6. Let's look at the other one. The frequency changed from 2 to almost 4. The wavelength also reduced from 1,75 to what? 0,9. Now look at the change. If here I take a calculator and say, I just want you to notice some changes. If I say here from what? From 3,9, right? If I divide by 2, you see this, it was almost 1,95, which is 2. Same thing with the 1,75. If I divide it by 2, it almost gives me the 0,875, which is 0,9. So you see that it's more like when you multiply by 2, here you divide by 2. Do you see that? When the frequency doubles, the wavelength halves. So you must remember that kind of relationship. Why? You can see that they are indirectly proportional. Alright. So what is the conclusion here? It says, conclusion, as the wavelength of a wave in a uniform medium increases. Uniform medium means, let's say there is the same medium, for example, air in 1 and air in the 2. So as the wavelength of a wave in a uniform medium increases, what is happening to the wavelength? The wavelength is going up. What will happen to the speed? We did mention that. Look at it. The wavelength is going up here from, let's use this one. In air, it increased from 0,9 to 0,75, 1,75. But look, the speed never changed. So what happens to the speed? It remains the same. No change in speed. Why? Because the wavelength does not affect. Remember, the wave speed will not be affected by the wavelength. Next one, as the wavelength of a wave in a uniform medium increases, so the wavelength here is going up, what will happen to the frequency? When the wavelength goes up, the frequency goes down, so it decreases. Remember, if you multiply by 2 on the wavelength, you divide by 2 on the frequency. Now, what conclusion can we say? We can say the wave speed of a wave therefore depends upon what? Upon the medium. Right. Depends, according to here, you can see that it depends upon the medium. I'm just looking at this diagram here. Not wavelength, not frequency, but only the medium. We moved from air to water. That's when it changed from 3.5 to 2,5. Do you see that? Just changing the medium. Look at it. Where in the air it became 2,5. Then we had water, all of a sudden it's 2,5. From 3,5 to 2,5, you can see that the medium affects that. Other factors that affect, as we said, it's temperature as well as the density of the medium. Those things will affect, right? So let's look at the conclusion. Even though wave speed is calculating by multiplying wavelength and frequency, this is very important now because they wanted to conclude maybe an experiment they've given. The wave speed is not affected by wave properties, What are the wave properties? Wavelength and frequency. Why? V is f lambda. So these are the wave properties. Changing the wavelength only affects the frequency in an inverse manner. So if you change the wavelength, frequency will also change. For example, doubling the wavelength results in halving the frequency, and the wave speed will remain the same. So the only thing that will affect wave speed is the medium. Okay, so don't forget that. Very important conclusion there. So let's look at a few examples here, and this is just to wrap it up here, and we'll do even more activities in the next lesson. Look at this activity. It says two waves on identical strings have frequencies in the ratio 2:1. If their wave speed are the same, then how do their wavelength compare? Can you try that one? So what we have, pause the video and try it and see what to come up with the answer here. We are saying two waves on an identical strings have frequencies 2:1. So the waves here, frequency of the waves is 2:1. All right, so these are two waves. So wave A has a frequency of 2 is to wave B is to 1, right? If their wave speeds are the same, so remember they are on the same medium, we say the same string, how do their wavelength compare? You must remember what we talked about, wave speed being the same as well as the only thing changing being frequency. So what did we say? If you're talking about frequency, the moment here it's 2:1, you just interchange. On the wavelength it becomes, so if this is frequency, so if frequency is 2:1, but when you come to wavelength, you must remember when frequency doubles, wavelength is half, and when wavelength, so here you divide by 2, it becomes 1:2. You see that? Why? Because it does the inverse. If the other one is twice, the other one is half. If the other one is half, the other one is twice. So the answer there becomes 2. Their wavelength will be 2:1. Are you getting that? That is, will maintain the speed. Remember, the speed must not change. All right. So for example, if I say, remember, V is frequency times wavelength. What is my frequency in the first one? 2:1. So the frequency will be V is equal to 2. So this is wave A. So this is my F, this is my wavelength. 2 times 1 is 2 meters per second. What about the second one? See, V is equal to 1 times 2, which is equal to 2 meters per second. I hope you got that. Last one for this lesson. Mac and Tosh stand 8 meters apart and demonstrate the motion of a transverse wave. So what's the distance apart? They are 8 meters apart. And then on a snaky, the wave can be described as having a vertical distance of 32 centimeters from a trough to crest, a frequency of 2,4 hertz, and a horizontal distance of 48 centimeters from a crest to the nearest trough. Determine the amplitude, the period, the wavelength of such and speed of such a wave. Obviously I need to sketch, but let's make sense of this. So they are standing 8 meters apart. So there is our 8 meters apart here. I hope I'm going to draw this part well. So this is Mac here, and this is Tosh, right? So what's the distance? It's 8 meters. And demonstrate the motion of a transverse wave on a snaky. The wave can be described as having a vertical distance of what? 32 centimeters, and a trough to crest. Listen to now, a trough to, okay, from a trough to crest. Let me read this properly. I'm not reading this properly. It's one sentence. The wave can be described as having a vertical distance of 32 meters from trough to crest, and the frequency, look there, frequency of what? The frequency is 2,4 hertz. and a horizontal distance of what? 48 centimeters from a crest to the nearest trough. Determine the amplitude, period, and stuff. So now we've got actually now let's draw this. They are telling me if I move from, this is the important distance that I'm going to use at this stage. If I move a horizontal distance of 48 centimeters from a crest, so if I move from here and do this, this is my crest, remember, and then they say from the crest to the nearest trough. So let me erase that 8 there. Let's go to the nearest trough. From the crest to the nearest trough, there is the trough. So of course if I go back like that, so now they are saying what is that distance. If I can mark that distance like this, to say this to that, and then I mark that distance. They're saying what is that distance? It's 48 centimeters. Let me use centimeters for now, but you'll divide later into meters. I think what they did there. So from a crest to the nearest trough. And then what else did they give? So remember now, whenever you are dealing with a wave length, we say it is distance from crest to crest or trough to trough. So now if I were to draw this wave and continue it like this, so now the question will be, what will be that distance? That is crest to crest. It becomes your what? Your wavelength, this one. Are you with me? So there are two things here. They told you frequency. I told you frequency is 1 over t. That's also that, which you can say the number of waves passing a given point in 1 second. That is fine. And also you have got formulas to say V is equal to what? Frequency times wavelength. So here they want us to find the amplitude, the period, the wavelength, and the speed. Are you with me? So the first one, if they wanted to find the amplitude is not a difficult part there. They told us the wave can be described as, there is the amplitude there, this is the amplitude. The wave can be described as having a vertical distance of 32 centimeters from trough to crest. Where is the trough? There is the trough. Where is the crest? Is somewhere here. See? So this line represents my crest. And then they say there is a vertical distance here of what? 32 centimeters. But now remember, what is an amplitude? Amplitude is not trough to crest, but is rest to crest. So rest is this point. Are you able to pick this up? This is your rest to that point. So what do you think is the distance? Or from rest to what? To trough. So you can see the distance is half. So this is 16. That is 16. So 16 plus 16 is 32. So the amplitude here is 16 centimeters. So there is the answer there for the amplitude. You're going to say amplitude is equal to 16 centimeters. Or you just say 32 divided by 2. So don't forget that. And then the next one, what is the period? Now we did say the formula F is 1 over T, or you can write it the other way around. T is equal to 1 over F, which is T is equal to 1 over, they told us the frequency is 2,4. So what is the period? It will give us the period as what? Which is 1 over 2,4, which is what? there it is. You see that? It's 0,417 seconds. 0,417 seconds. Period is in seconds. And then now they want the wavelength. Now look at this now. When they're talking about the wavelength, and they used this part to say from trough to what? From crest to trough. Look at this. You are moving here to say from crest. Let me just show you here. If I say I'm moving, let me use something different just to explain. If I say I'm moving from here, I'm going down to there, you can see that this is half a wave. This is half wave. That's half a wave. It is good as moving from here to here. This is also half a wave, right? So which means if this distance is 48, what about the next half wave? The next half wave, if I can draw it, it will be this distance from here up to there. You see that? So it will also be what? If I can use that part, that distance also will be what? Will be 48. You see that? So we're going to have this distance as 48 centimeters. You see that? So now if you add 48 plus 48, the wavelength now, crest to crest, you can see that that is your 96 centimeters. You see? Which is 48 plus 48 is 96 centimeters. So the wavelength is what? 96. So I can say wavelength is 96 centimeters. Now the speed of such a wave, now you follow up the formula now to say V is F times lambda, which is equal to V is F is 2,4. They gave us 2,4 here. That was our F. But lambda, the wavelength, don't use for 96 centimeters. Just first convert. Wavelength is 96. When you're converting centimeters to meters, divide by 100. You see, which is 0,96 what? Meters. See, that's how you convert. Then that's what you're going to multiply here as 0,96 meters. Then your V will be then equal to what? Then you can use that to say 2,4 times 0,96 equal to V is 2,304, which is 2,30 meters per second. And we have another formula which said V is what? Here it was remember frequency, it was wavelength over T, and 0,96 over T being period. If you check the previous formula, which is 0,417, 0.417, and you can also use that and then check if it gives you the answer that is same. 0,96 over 0,417, and then it gives us 2,30, and then it's meters per second. And if you compare the answers, you can see that it gives us the same answers. All right, so this, guys, is what you do when you're approaching these questions. But guess what? I'm going to be dealing more with these now. These are previous papers now, where I look into what you expect in a previous paper. You see, I'm going to be going through this in the next lesson. We're going to go through such questions. Now this is what now they bring for your exam. See this? I'm going to be answering these questions. Look at this, there is more to come. We're going to be answering this. So I just want you to join me in the next lesson, so you can try them. Look at this question. All right, there it is. This particular question, it's 12 marks. You can try it, pause the video, study the question as they have given below, like that. You study it and then try to answer these questions. All right, so there is the question in full. Let me try to fill it up like this. All right, then the previous question that you can try as I did was this question. Can you try it? says the first one on the answer sheet, try that one right there, and then also you are given that. So guys, join me in the next lesson as I'll be covering this part of the questions, and they are very important for you as you prepare for your final exams. We've come to the end of our lesson. Join me in the next lesson. Remember, to be subscribed is an advantage. Subscribe and ensure the notification bell is turned on. Thank you.